Hey everyone, we're going to talk about moral probability today. And before we get into new stuff, I just want to remind you earlier we talked about mutually exclusive and how those are things that cannot happen at the same time. So if you were going to draw like a Venn diagram, you'd have one event and you'd have another event, and I made them as circles. But since they can't happen at the same time, they won't ever overlap. So it would just be two things that never touch because they can't happen at the same time. Um, most of our video today is about these things called overlapping events. And these are things that can happen at the same time. So let's say they don't have to happen at the same time, but they can, right? So you have event one and event two, just two things that could happen at the same time. They might not, and then they would be separate like this. But if they do happen at the same time, you would get like a Venn diagram type thing where you would have event one, whatever it is, overlapping event two, and then this little place would be things that fall in both categories of event one and event two, and that would be the happening at the same time that this talks about at the top. Okay, so we're talking about overlapping events. So before I tell you how to do problems with them, I'm going to give you some examples. So, for example, on a number cube, which is really just a dice, you could roll a number that is odd. So our odd numbers on a dice are 1 and 3 and 5. And you could roll a number that's less than 4. And those numbers are 1 and 2 and 3. And then if you look at the list you just made, 1 and 3 are on both of those lists. So those are the overlapping events because they can happen. You can roll something that is odd and less than 3. You don't have to, but you can. Right? In a deck of cards, you could pick a card that is a red card and a face card. So your red cards are the hearts. Actually, I'm going to do this in red. In a card deck, your red cards are the hearts and the diamonds, right? And your face cards are the jack, the queen, the king. Does an ace count as a face card? I don't know. But anyway, so you could reach into your deck of cards and you could pick out the king of diamonds, right? And that would be something that is red and a face card. So that would be the overlapping. Okay. So those are some examples of overlapping events. And now we're going to talk about how do you solve problems with these things. So let's see. This one we says, what is the probability that you roll a number that is greater than 2 and an odd number on a number cube, which again is just a dice, right? So on your number cube, the options you can roll are 1, 2, 3, 4, 5, and 6. Okay, so first we're going to look at the probability that you roll a number that's greater than 2. Okay, so you look at your list. There are the things that are greater than 2 are 3, 4, 5, and 6. So there's 4 things that are greater than 2, and there are 6 total options. So the probability that something is greater than 2 is 4 out of 6. Now we're going to talk about the probability of an odd number. Right? So on your cube, your odd numbers are 1, 3, and 5. So there's 3 of those, so that probability would be 3 out of 6. But, as you can tell, 3 and 5, I underline them both, right? Because they're both greater than 2 and they're both odd. So if we try to do this, and all we do is take our 4/6 and our 3/6 and add those together, what we've really done is we've counted the 3 and the 5 twice. We counted it once when we said they're greater than 2. It's part of those 4. and we counted them when we said that they're odd. Okay, so the 3 and the 5 we counted twice. So what we're going to do is we're going to subtract the probability of a 3 or a 5. So the probability of getting a 3 or a 5 is 2 out of 6. Okay, so we took our two individual probabilities. Greater than 2, there's 4 of them. Odd numbers, there's 3 of them. But we counted the 3 and the 5 twice. So we need to subtract off one of those, right? So if it's like if we made a list of the things that are greater than 2, we'd have 3, 4, 5, and 6. And if we made a list of the things that are odd, we'd have 1, 3, and 5. And if we were just going to put these together and make one list, you wouldn't write 3 twice, you wouldn't write 5 twice. You would just make a list of 1, 3, 4, 5, and 6. Okay, right? You're not going to write the 3 twice on your list and the 5 twice on your list. You're only going to write them once. Okay, so we need to subtract the fact that we doubled those up. So 3 out of 5, the probability is 2 out of 6. So we took our individuals 4 and 3, added those together, and now we're going to subtract 2 out of 6, which is 3 plus 4 is 5, minus 2 is, just kidding, 4 plus 3 is 7, minus 2 is 5. So this is 5 out of 6. And that is your final answer. Okay, and if you look in your list, there's only one number that isn't underlined, and that's 2. So we've got 1, 2, 3, 4, 5 things, right? 1, 2, 3, 4, 5 things that fall in the category of being greater than 2, or together, when you put this whole list together, they fall in the list of being greater than 2 and an odd number. Okay, so just in general, for overlapping events, you do, so we have events A and B, and they overlap. Okay, so your little formula is you do the probability of one of them, you add the probability of the other one of them, and then you subtract the probability of both of them, or the other way to write it would be probability of one of them plus the probability of the other one, and then you subtract the things that are A and B. Okay, so probably, maybe, should write one of these formulas down so that you have it. And in terms of a Venn diagram, you have, we'll call this event A, we'll call this red circle event B, and then this part in the middle where they cross, that's A and B, right? Those things in the middle, they fall in the blue circle, but they're also part of the red circle, right? And if you want to think about the Venn diagram, you wouldn't, like if you were just drawing this, you would draw all of the blue circle, and then maybe you would draw this part of the red circle that's missing. You don't have to draw this inside part again because you already took care of it with the blue circle. Okay, so you add the individuals, you subtract the part that is overlapping. So we're going to do another example. Okay, and this one is about alphabet. So this says, what's the probability that you pick a letter in the first 10 letters of the alphabet and a vowel? So there are 26 letters in the alphabet. I'm not going to write them all out. That would take too long. So the first 10 letters of the alphabet are A, B, C, D, oh gosh, E, F, G, H, 8, 9, A, B, C, D, F, G, H, I, and J. Okay, so those are the first 10. So then the probability that you pick something that's the first 10 would be 10 out of 26. And then let's think about the vowels of the alphabet. You got A, E, I, O, and U. We're not going to count Y in this example, right? It's A, E, I, O, U, and sometimes Y. We're not going to count Y right now. So the probability that you pick a vowel is 5 out of 26. Okay, so if we just start by adding those, do the probability of the first 10 plus the probability of the vowel, you would have 10 out of 26 plus 5 out of 26. However, A and E and I are on both lists. They are vowels, and they are in the first 10 letters of the alphabet. So what we did is we counted them when we did the first 10, and we counted them as vowels. So if we stop right here and add these things together and write 15 out of 26, we've counted A and E and I twice, which we don't want to do. So now we're going to subtract the probability that you get an A, an E, or an I, because those are the things that are in the first 10 and they're the vowels. We've counted them twice, which is bad. And since there's 3 of them, that probability would be 3 out of 26. And so when you finish this off, 10 plus 5 is 15, minus 3 is 12, so this final probability is 12 out of 26. There you go, done. So that's a little bit tricky because you have to figure out what part is overlapping, and so sometimes finding the subtraction piece is a little tricky, but it can be useful also. So you will watch this video, hopefully you just did that, and then after this video there will be another link posted in Schoology if you want another example about these overlapping event things.